All right, in this video, we're going to work through the following indefinite integral. We have the indefinite integral of e to the inverse secant of x power. All of that's divided by the absolute value of x times the square root of x squared minus 1 dx. Okay, so looking at this integral, this is certainly not a basic integral, right? It's not just a derivative fact in reverse. So this is more complicated than that, which for our class, Cal 1, means that this is going to be a substitution integral. All right, and so in a substitution integral, then what you want to do is to pick u, right, to be equal to something. So in this one, there are a number of things, right, and they all point to secant inverse being the correct choice for you. Number one, right, is that secant inverse, it's a function. If you think about it, we know what the derivative of that is, right? That's just one of the basic derivative facts. But notice we haven't really talked about what the integral of the inverse secant is at all in this class. And that's because, that is a fact, or not really a fact, but a technique that you would use in calculus 2, okay? And so, and the same thing kind of holds for the inverse sine and the inverse tangent, right? Those are functions that we know the derivatives of, but if you think about it at this point, just what we learned in this class, we don't know what the indefinite integral is, or the antiderivative of that is. So almost any function like that in this class means that, you're going to choose u to be that. Another kind of dead giveaway is on a lot of these problems with e, right? The exponent really is the inside part here. So on the list of good choices for u, it really satisfies number one, right? Secant inverse is the inside part. That is a hard thing for a lot of people to see because it doesn't really look like it's inside, right? The way that we write this. So it's also one of the other bullet points on that list of good choices for you is things that are the exponent of the e. And so in this case, this is the correct choice for you. Not only that, right, in the next step, when we go to calculate du, right, or the derivative of the inverse secant is 1 over the absolute value of x times the square root of x squared minus 1. And so you can see that lots of parts of the derivative of secant inverse of x appear in the integrand, right, down in the denominator here. So 100%, right, this is the correct choice for you here. The next thing that we need to do is to switch all occurrences of x, right, over to using these two equations here, okay? All right, and so it's pretty easy to see that, okay, for secant inverse, we're going to put u, but it might be a little bit more difficult for you to realize how this, this fits into the picture. And so what you need to do to make it easier is to kind of pull this apart. And if you pull it apart, then it's a little bit easier, should be a little bit easier to see, right? If I pull that e to the inverse secant apart and then have 1 over x square root x squared minus 1 off to the side like this, then it's easy to see, okay, where these things get substituted. And now you might be a little skeptical and say, hey, how do I know that these two things are equal to each other? Well, if you want to think about that, then if you wrote this e to the secant inverse of x as being over 1, which it certainly is equal to, right, because anything divided by 1 is itself, and then multiply these two fractions together, you'd see that on the tops you get e to the secant inverse of x times 1, which is certainly this one here, and then on the bottom you get 1 times absolute value of x times square root x squared minus 1, which is exactly equal to what you would get here. So multiplying these two fractions together gives us exactly this expression here. So they are equal to each other. And then with the e to the secant inverse, right, anything over 1 is itself. So you don't really need to write that over 1. Okay? All right. And so now that we've pulled it apart like that, then we make our substitutions. We can see that secant inverse, right, that's equal to u. And this 1 over absolute value of x squared minus 1 times dx is exactly what we have here. All of that stuff is exactly equal to du. All right, so not only did this substitution make our integral much simpler, which is the goal of any of these substitutions that you make, to make it simpler or maybe just doable in the more difficult cases, but not only did it boil it down to something simple, this is actually the simplest integral possible, right? Because e to the x is its own derivative and its own antiderivative, therefore, and so the integral of e to the u is just e to the u plus some constant c. Okay, and now we just need to back substitute. We know that u is secant inverse of x and plus some constant c, and that is it on this one.